This is section 12.1, Surveys, Observational Studies, and Experiments. In the box at the top, we have an example of a survey. Students at a new school wanted to form a basketball team. In order to get funding for the program, they carried out a survey of students and their parents to determine who was in favor of starting the team. So a survey, like this one, is used to collect information about a population. And then the population is an entire group of living things or objects. So in this case, the students are asking parents and students, so the whole population would be all students and all parents at this school. Sample is just a portion of the population. And so when we're looking at this example, the sample are the parents and students who actually participated in the survey. They probably weren't able to talk to every single parent and every single student, so the sample is who did they actually get information from. Now we can have biased survey or unbiased survey. A biased survey is when it favors an outcome, and unbiased is where there isn't going to be one outcome that's more likely to get chosen than the other. So we're going to look at example 1, and we're going to determine if they're biased or unbiased. And I'm going to write if they're biased or unbiased next to them as we go over them. This actually says to explain. I'm not going to write the explanation. I'm just going to tell you why that is, because there's not a whole lot of room for me to be writing all of that down. We're going to state whether the survey is producing a random sample. We're going to write yes or no, and like I said, we're going to talk about it. The first question, question A, says asking every 10th person coming out of a theater how many times a week they go to the theater to determine how often city residents support the performing arts. So we want to ask ourselves, is this biased or is this unbiased? And in this case, this is going to be biased because this is only surveying the people who are coming out of the theater. Those people who are coming out of the theater are going to be more likely to go to the movie theater than probably the rest of the population because they're there at the time. So we're going to go ahead and write no on this one because this one is not a random sample. B says surveying people going into a pet store to find out if the city's residents support the building and maintaining of a dog park. Again, we're only talking to this one specific group of people, and even with that, these people are the people who are going into the pet store. So people who are going into a pet store most likely have pets and are going to be a lot more supportive of things involving pets. So this one is also not going to be random. It's going to be biased. And then C, a box contains the name of every student in the school. 100 names are randomly pulled out of the box. Those students are asked their opinions on the new cafeteria rules. Now in this case, this is every student in the school, and then we're randomly selecting some of these students to give us their opinion. So this one is going to be random. We can also say yes on this one because everyone in the population has an equal chance to be part of the sample. In example 2, we're looking at survey design. We're saying how can we design a survey so that it best gives us unbiased results. The scenario says that Christopher wants to determine the most desired location for the senior class trip. Which questions will get him the answer he is seeking? Question A says, do you like Disneyland? Now this is very, very biased because this is only asking them about one location. It's not giving them any other options. It's just favoring Disneyland because if people hear the word Disneyland, they're going to be more likely to maybe want to go there. So it's pretty biased. B says, which is better, Kings Island or Cedar Point? Again, very biased because there's only two options that are given. And C says, where would you most like to go on the senior trip? This is unbiased, and it's going to produce the answer that he's looking for. It's going to get people to tell him what they think without hearing any options, and so that's going to be the best choice. We're going to skip the your turn because that's actually going to be one of your homework problems, and we're going to go on down and we're going to look at observational study and experiment. So an observational study is where we're just having individuals be observed. We're not trying to influence them whatsoever. We're just watching them. So watching and not trying to influence. And some examples are we have an example here that we're going to get a pond that's being affected by fertilizer runoff, collect samples of the water, and analyze and interpret the data. So in this case, they're not actually changing anything about the water. All they're doing is collecting the water and then figuring out the information based off of that water. Some other examples would be if I were to give a test to my students and I wanted to see who finished first, I would just watch the class. That would be an observational study. I wouldn't really be affecting them. I wouldn't be telling them to turn the test in. I would just be watching, and maybe I would want to do that to see, maybe I'd be searching and seeing, okay, if someone spends more time on a test, are they going to get a better grade? So maybe then I would just observe who turned the test in, and then if they turned it in first, see if they get a really high grade or if they get a really low grade. An experiment is where something is actually done. You're actually affecting either people or animals or objects, and then you're seeing how they react. So an experiment would be like taking a sample of pure water, saturating the water with dissolved oxygen by using a bubbler, and then removing the bubbler and beginning to heat the water while measuring both its temperature and its dissolved oxygen. So in that case, you're actually doing something to the water. You're heating it up. So you're trying to actually change it and see what effect is happening. So here, I'm going to go ahead and write down something is intentionally done. And that'll help you be able to tell the difference between observational study and experiment. Because with the experiment, you are actually doing something. And you're probably familiar with experiments from your science classes. So in an experiment, the people, animals, or objects given the treatment are called the treatment group, and those that are given the placebo or the false treatment are the control group. The placebo is given so that none of the participants will know which group he or she is in, and the experiment will be unbiased. In example 3, we're looking at experiments and observational studies. So we're going to state whether each situation represents an experiment or an observational study, and if it's an experiment, we're going to identify the control group and the treatment group. Then we're going to determine whether it's biased or not. So in example A, it says that we're going to find 200 students, half of whom participated in extracurricular activities, and then we're going to compare their grade point averages. In this case, this is just an observational study because we're not actually doing anything to the students. We're just taking information about them and looking if there's a difference. So we're just observing. We're not actually doing any type of experiment. In example B, we're going to find 200 people and randomly split them into 2 groups. One group is going to jog 2 miles per day and the other group is not going to jog at all. In this case, we're actually telling some people that they need to do something. So this is going to be an experiment. So since it's an experiment, it says that we have to identify the control group. The control group, in this case, is going to be the people who aren't jogging. And then our treatment group is going to be those who are running the 2 miles a day, or the joggers. This is actually going to be biased because each of the people are going to know which group they're in. So looking at the next example, we're going to be talking about correlation and causation. So when two things are correlated, that just means they're going to be related, and you can actually relate anything that you want. So if I study for the test, I will get an A on the test. Whereas causation, it's where one event is the direct cause of another event. So our example is if we have a level 2 snow emergency, we do not have school. So in the first event, we are looking at 2 separate things, but studying for one test doesn't necessarily mean you're going to get an A in the whole class. You could do really, really well on that one test and fail all of the other tests. So it's not a cause. The studying for the one test isn't going to cause you to get the A in the class. Whereas in the second example, if we have a level 2 snow emergency, we don't have school. Not having school is a direct result of having that level 2 snow emergency, which is why it's going to be causation in that case. In example 5, we're going to be determining if each of the statements shows correlation or causation, and we'll talk about why that is. So a good way to determine if it's causation is to see, is there another alternative that could be causing the situation? If there is another alternative, it's going to be a correlation. If there isn't, then it's going to be causation. Example A says that studies have shown that students are less energetic after they eat lunch. So in this case, there could be another reason after they eat lunch that they're less energetic. So we would just be classifying this one as a correlation. They may not be causing one another. Our second example says, if I lift weights, I can make the football team. Well, that might not be the case. I know that if I were to lift weights, that's not going to make me make the football team because I am a tiny female. So there's another reason that you could be making the football team or not be making the football team. So again, this is a correlation. And then in example C, it says when the sun is visible, we have daylight. So again, we're thinking about, is there another alternative? In this case, there's not going to be another alternative, and so this one is actually going to be causation.